lot of infrastructure in the Netherlands and in Germany has been built in the 50s and 60s with intention to have a surface life of 50 years at that time. That time actually comes now, and there is a question how to deal with existing infrastructure, how to extend the surface life of existing infrastructure in a smart way, let's say. All answers regarding smart asset management and concrete durability related issues will give you the project Asset Management 2.0. The first pilot project has been started in Mönchengladbach, where we embedded 8 of these sensors in the bridge with intention to have real-time durability monitoring. The idea is that in the future, if anything happens in this bridge, let's say, this sensor would be able to send an early warning signal to our company in Competence Centrum, where we created an interpretation methodology, and at the same time we create the value of information. So what we do, we measure, we collect the data, we interpret the data, and we create the value information and very pragmatic advices for asset owners.
We have developed a real-time concrete durability sensor which will measure the quality of concrete cover remotely. This sensor will be embedded in concrete like this, in the concrete cover, and it will measure the concrete cover penetrability towards aggressive substances. It will measure the concrete resistance at different level in the cover depth, and with this it determines the concrete cover penetrability. Moreover, this sensor will determine the cracks inside concrete. Our sensor is a completely wireless sensor, but at lab scale we are using a cable version. Since we have a lot of calibration experiments, with these calibration we will correlate the deterioration of concrete with our sensor data.
The sensor sends data, but without the right interpretation methodology, this data has no significance. Moreover, concrete is a very heterogeneous material. That's why we cast 10 different types of concrete, embed sensors, wired sensors in this case for lab experiments, and do a lot of tests. First set of experiments are the calibration tests. Here we monitor data of all these mixes in different climate conditions. We have the wet climate conditions, we have kind of a dry climate conditions here in the lab, and we had the outside conditions where the climate is continuously varying. The second set of experiments that we do are accelerated degradation tests. Here we have the accelerated carbonation test, we have the rapid chloride migration test, and here we have the freeze and thaw chamber where we run accelerated freeze and thaw tests. You can see all the samples that are being run here all the day and monitored continuously. These tests give us 2 inputs. One are the limit states necessary for the decision support tool, and 2, it helps us validate all these experiments against standards and codes that is extremely necessary.
The ultimate goal of the project is to create predictive maintenance in the future for the asset owners who would be able to have appropriate balance between the risks, costs, performance, availability and maintainability of the infrastructure. How are we going to do this? In the Concrefy, we are going to create the decision support tools which will facilitate the decisions of asset owners to take always the most optimum decisions at specific moment. When to spend the money and when to save the money, and how to develop the most proactive approach in the future. So fresh thinking for construction.